Here's a fact that should stop every developer cold. Someone took rsync, the unglamorous file-copying tool quietly running on hundreds of millions of machines worldwide, and asked one blunt question. Did letting an AI like Claude help write its code actually make it buggier? Most people assumed the answer was an obvious yes. The reality turned out to be far stranger. Rsync isn't some toy project. It's 30 years old, it moves your backups, your website deployments, your Linux updates. It's the invisible plumbing of the internet. So when a researcher published a deep analysis on the 5th of June claiming to measure whether AI-assisted commits introduced more bugs, the developer world leaned in hard. Think of rsync like the postal service for computer files. Every night, millions of automated jobs hand it precious cargo and trust it to deliver every byte intact. Now imagine someone audited 30 years of that postal service's delivery records, then compared the mistakes made before and after a new robot assistant joined the sorting room. That's exactly what this analysis did line by line, commit by commit. And the headline everyone shared online got the story almost completely backwards. The data showed something nobody screenshotting the title actually bothered to read. Was Claude the villain here, or the scapegoat? The truth sits somewhere most hot takes never reach. And here's where it gets interesting. To understand why this study matters, you need to know what rsync actually does. Picture two folders, one on your laptop, one on a server across the world. Rsync compares them and copies only the differences, not the whole thing. That clever trick is why it's survived since 1996 and why it's baked into nearly every Linux and Mac system on the planet. When you back up photos, when a company deploys a website, when scientists move terabytes of telescope data, rsync is usually doing the heavy lifting. Now here's the tension. In early 2025, security researchers found 6 serious vulnerabilities in rsync at once, including a critical flaw that scored 9.8 out of 10 on the danger scale. That bug could let an attacker run their own code on your machine just by you connecting to a poisoned server. For a tool this trusted, that was a 5-alarm fire. Around the same time, the project quietly started accepting more AI-assisted contributions. Maintainers are volunteers, often just 1 or 2 exhausted people, and tools like Claude promised to lighten the load. So the timing created a perfect storm of suspicion. New bugs appear, AI shows up, people connect the dots and assume the robot broke the plumbing. It's a tidy story. It's the kind of narrative that spreads in hours. But correlation isn't causation, and this researcher decided to actually check the receipts. Here's the twist nobody expected. So how do you actually measure whether AI made code worse? This is where the analysis gets clever. The researcher pulled the entire Git history of rsync, every single change ever made, going back decades, and tagged each commit. Which ones came from long-time human maintainers? Which ones showed fingerprints of AI assistants, like the telltale phrasing in commit messages or the suspiciously uniform style Claude tends to produce? Then they tracked which of those commits later had to be fixed because they introduced a bug. Think of it like a restaurant tracing food poisoning back to a single kitchen station. You don't just count sick customers, you follow each bad dish back to the exact cook and the exact moment it was prepared. That's bug attribution, and it's painstaking work. The key number here is something called bug introducing change rate, basically. What percentage of someone's commits later needed an emergency patch? For human maintainers on rsync, that rate historically sat around a few percent, which is normal for gnarly low-level C code. The expectation was that AI commits would blow past that. Memory bugs in C are notoriously easy to write and brutally hard to spot. Claude, the theory went, would confidently produce code that compiles, runs, looks perfect, and quietly corrupts memory under rare conditions. A polished landmine. But when the researcher actually crunched the attribution data, the numbers refused to cooperate with the popular narrative. This is where it gets complicated. Let's get specific, because this is where it stops being abstract. The analysis dug into individual AI-assisted commits and what they actually changed. In several cases, Claude was used not to write brand new features, but to refactor old, crusty code and add safety checks the humans had skipped for years. One example involved bounds checking, making sure the program never reads past the edge of its memory buffer, which is exactly the class of bug behind that critical 9.8 vulnerability. The AI-touched code, in those instances, was more cautious than the human original, not less. But it wasn't a clean sweep. The researcher also found cases where AI-generated changes added unnecessary complexity, extra layers of code that did nothing useful but created new places for bugs to hide. Imagine hiring a contractor to fix a leaky pipe. And they fix it perfectly, but also install 3 extra valves you'll never use, each one a future failure point. That's the double edge. So picture 2 stacks of commits side by side, 1 stack of human changes, 1 stack of AI-assisted ones. When you count the bugs that actually shipped and hurt users, the AI stack wasn't dramatically taller. In fact, on the specific metric of memory safety bugs, it was slightly shorter. The real problems clustered somewhere far less dramatic than the headlines screamed. The story the data tells isn't AI good or AI bad. It's something messier and far more useful. But here's the kicker. Now let's put this in context, because rsync isn't the only place people are running this experiment. Across the software world, studies of AI-assisted coding keep landing on the same uncomfortable middle ground. AI doesn't write magically perfect code, and it doesn't write uniquely terrible code either. It writes roughly human-quality code, faster. And that speed is the real plot twist. Think of it like a chess engine that plays at a strong amateur level, but moves in 1 second instead of 10 minutes. The skill ceiling isn't superhuman, but the volume is. One developer with Claude can produce in a day what used to take a week. Here's the catch that the rsync analysis exposes perfectly. When you generate 10 times more code, even at the same bug rate, you generate 10 times more bugs in raw count. The percentage holds steady, but the absolute pile grows. So a maintainer reviewing AI-assisted contributions isn't drowning because the code is worse. They are drowning because there's so much more of it to check. Compare that to the old days when writing code was the slow part and reviewing was fast. AI flipped the bottleneck. Now writing is instant and careful review is the scarce, expensive resource nobody budgeted for. That's the change almost every hot take missed. The danger of AI coding isn't that it's secretly sabotaging your software. It's that it quietly overwhelms the one human safeguard that catches mistakes. And this is where things get surprising. So what does this mean for everyone who isn't an rsync maintainer? More than you'd think, because rsync is just the canary in the coal mine. Almost every app on your phone, every website you visit, every banking system sits on top of open-source tools maintained by tiny volunteer teams. These are the unpaid people holding up the digital world with duct tape and stubbornness. Now picture that overwhelmed maintainer suddenly facing a flood of AI-generated pull requests from strangers, polished, confident, plausible-looking code that takes real effort to verify. Some of it genuinely helps. Some of it hides subtle flaws. And the maintainer has to tell them apart, alone, for free, after their day job. That's the real security story here. Not killer robot code, but a review bottleneck that attackers can exploit. A bad actor could deliberately submit AI-polished code designed to look helpful while smuggling in a vulnerability, knowing the exhausted maintainer might wave it through. We've already seen attempts exactly like this in other open-source projects. The numbers make it stark. A single critical bug in a tool like rsync can expose millions of servers overnight. And the people standing between you and that disaster are often a handful of volunteers staring at a growing queue. AI didn't create that fragility, it poured gasoline on it. The convenience we love on one end becomes pressure on the most overlooked people in tech on the other. Here's what the headlines aren't telling you. So how do you protect yourself in a world where AI writes more and more of the software you depend on? Whether you're a developer or just someone who runs a computer, there are concrete moves that matter. First, if you write code with AI help, treat its output like a draft from a brilliant but overconfident intern. It sounds sure of itself even when it's wrong. Read every line. Ask it to explain why each change is safe. Then verify that explanation yourself rather than taking it on faith. Second, lean hard on automated testing. Write tests that try to break your code with weird, hostile inputs, the exact edge cases where memory bugs hide. Tools that scan for these flaws automatically, called static analyzers, catch a huge share of the issues a tired human reviewer would miss. Run them on everything, human or AI written. Third, if you maintain or rely on open source projects, support the maintainers. sponsor them, report bugs clearly, or just help review. The review bottleneck is the real weak point, and more careful eyes is the only real fix. And for everyday users, the practical takeaway is simple. Keep your software updated. Those boring update notifications are often patches for exactly these kinds of bugs. The rsync flaws were fixed fast, but only the people who updated got protected. The gap between a patch shipping and you installing it is the window attackers live in. Now here's where the real story starts. So here's what this all means for you. The rsync story isn't a warning that AI is quietly poisoning our software. It's something more nuanced and honestly more important. AI coding tools are about as accurate as a skilled human, but vastly faster, which means they flood the system with far more code than anyone can carefully check. The bug rate didn't spike. The review burden exploded. And that's the real challenge of the next decade. We've spent 2 years asking whether AI can write code. The rsync analysis quietly proves we've been asking the wrong question. The one that matters is whether we can review code fast enough to keep up with how much AI now produces. Whoever solves that bottleneck, better testing, smarter analyzers, AI that reviews other AI, wins the next era of software. So watch for that. The headlines will keep screaming about AI breaking things. But the quiet revolution is in the tools being built to catch the mistakes. That's where the smart money and the real innovation are heading. And next time you see a scary headline about AI sabotaging code, remember rsync. Check whether anyone actually read past the title. The truth is almost always more interesting than the outrage. If this changed how you think about AI and code, you'll want to stay close, because this story is moving fast. Follow for daily AI news, and I'll keep breaking down what actually matters beneath the hype.